No, I can't now.
Say again. Say again.
Wait, we're all what? What are we
You're all great kids.
Say again.
Y'all are all just beautiful children.
I thought you said worthless, but.
No, I didn't say that.
Your mom.
Worthwhile does sound a lot like worthless.
Yes.
And that's what I said. You're all very worthwhile.
Uh-huh.
Okay, so today, like I accidentally put on that homework problem, we're talking about geometric sequences. And I think you guys probably could wrap your head around this pretty quickly. Yesterday, when we talked about arithmetic, we were doing what? What was constant? It was either adding or subtracting yesterday. Yesterday was either adding or subtracting, right? If the difference was positive, it was adding. If the common difference was negative, it was subtracting, right? That's what yesterday was all about. So guess what today is when we say geometric? Multiplying or multiplying, okay? Not technically multiplying or dividing, and there's a reason, and we'll talk about that in just a second. But when we talk about geometric, we are talking about multiplying or dividing, but we're really only talking about multiplying, okay? And you'll get that, I think, in a second. But when we define geometric sequences, we define it as a sequence in which the ratio between any consecutive terms is constant. So instead of us finding a common difference, we're finding a common ratio. And again, if you think about it, the reason that today's lesson can be easy, if you understood yesterday, is the ideas behind everything that we're doing is the same. Like, for example, yesterday we found the common difference. How? We did a sub 2 minus a sub 1. Well, today we're checking to see if it's geometric, so we're doing a sub 2 divided by a sub 1, okay? And that will give us our common ratio. Now, before we get into an example, let me explain why I said we're really just multiplying. What is the same thing as dividing by 2?
Multiplying by 0.5.
Multiplying by 0.5, or multiplying by 1/2, right? So that's really what we're going to talk about today. Whenever we're dividing by 2, we're not going to really have an equation that involves division. It involves multiplication, but with a fraction. So instead of dividing by 2, we're going to be multiplying by 1/2. Instead of dividing by 4, we're going to be multiplying by 1/4. You get the point? So geometric sequences are dealing with problems that the numbers are either multiplying or dividing by a consistent number. But when we write the formula for them, they're going to look like it's multiplying all the time. It'll just be fractions that make them get smaller. So first thing we're going to do is we're going to check to see if a sequence is geometric. So my process is just like yesterday. We're going to see what the common ratio is, and we're going to see if that common ratio is what is consistently happening. So remind me, how do we find the common ratio? The common ratio. I want to hear it louder. I hear whispering. Johnny T. Like, what? What's he saying back there? And I'm telling y'all, Johnny is about right 92% of the time. But you never heard her because she's like, all right, you take the second term and you, no, divide by the first term. What's the second term? What's the first term? We divide 12 by 6, and that is? Okay, so here's what this means. We're not adding 2. It's a common ratio. We're multiplying by 2 every time. That's what we're checking. Okay, so what's 12 times 2?
24.
Yep, 24 times 2?
48.
Then this is what?
Geometric.
This is geometric. Now I'm writing the right answer. Right, Michael? So how do I find the next 3 terms? You keep
Going.
multiplying by 2. What's 48 divided by, or times 2?
96.
96. What's 96 times 2?
192.
And then finally, what's 192 times 2?
340 something. No.
No.
That's Aiden saying the wrong answers.
384.
Sorry, I don't know. I want to make sure everybody knows. It's 384. All right, so that's pretty simple, right? Let me show you the opposite side of this. If you look over here at number 2, how do we find that common ratio?
A2 divided by A1.
So 270 is A2, my second term. 810 is A sub 1, that's my first term. So when I type in 270 divided by 810, if you don't use alpha y equals number 1, it's probably going to write it as a decimal. Is this a terminating decimal? Or is it a repeating decimal? We don't like repeating decimals in our work, so we're going to change this back to a fraction. Remember how to do that? Alpha y equals number 3. And it is
1/3.
1/3. So listen, guys. Technically, we're checking to see if this thing keeps dividing by 3. But because our formula with geometric deals specifically with multiplication, we're seeing if it multiplies by 1/3. It's the same concept. But we're going to keep multiplying by 1/3 to see if it follows that pattern. So get out your calculator and go 270 times alpha y equals number 1, 1/3.
Is that not the same thing as 3?
Huh?
Is 1/3 not? That's not 3.
No, it's not. It's like dividing by 3. It's like dividing by 3. Yeah. So that worked. What's 90 times 1/3? So is this geometric? Yes, just like the last one, it is. So we're going to find the next 3 terms. Whoa. So this is where it gets a little tricky for some of us. What's 30 times 1/3? 10. That's not too bad. Again, be comfortable with alpha y equals number 1. What's 10 times 1/3?
3.3.
I like to leave it as a fraction, so I'm going to go 10/3 or 3 1/3, but I would rather leave it 10/3 personally. And then what's 10/3 times 1/3? 10/9. So that's my next 3 terms. This is the way I would like to leave them. Okay? All right, and let's look at one that's not. Look at number 4. Let's find our common ratio. Once again, how do I do it?
A2 over A1.
So A2 is 8. A1 is 4. What's 8 divided by 4?
2.
So I should keep multiplying by 2 here if this is a geometric sequence. What's 8 times 2? Not 20. So it's not geometric. Jace. Jeez. You're talking, so pretty much you get a punch you in the face. Because jeans means you can't keep talking. We said the same thing at the same time. I said jeans.
Well, what if I already said?
You didn't say it.
He did. I heard it.
You said jeans.
Yes.
Lies.
He said it right before you. Right after we said this. And you know. So he gets to punch you in the face.
Yeah.
And we get to record it.
I'm gonna check the tape.
You don't have to do that.
Alright, so pretty easy to determine if something is geometric, right? Just like yesterday with arithmetic. It's just we're dividing a sub 2 by a sub 1, and we're seeing if that is the pattern that continues. Multiplying by whatever that value is. Alright, now, next, what if we know something is geometric? We figured it out, it is geometric, and now we want to write the equation. Here is the equation for a geometric sequence. A sub n equals a sub 1 times my common ratio raised to the n minus 1 power. Now, do we know all those values? Of course we do. What's a sub 1? That's my first term. What's r? We just called it common ratio. And then, of course, we know that n, in most cases, is just a variable. Excuse me. It's just a variable. Now, listen, this equation, in my opinion, is easier than the other one. Because if you remember the other one, once we plugged a sub 1 and the common difference in, we had to distribute, and then we had to combine like terms, right? With this equation, when you plug them in, you're done. Look, we've got to first find the common ratio. So look at number 5. How do we find that common ratio? Knowing that it's a sequence. A sub 2, which is divided by a sub 1, 1. What is negative 5 divided by 1?
-5.
So my common ratio is negative 5. So ready? Here's my equation. After I write it, it's done. A sub n equals, what's a sub 1? 1. Open parentheses. What's r? Negative 5. Close parentheses, raised to the n minus 1. And now this equation is done. What you will never do, say it, I will never do.
I will
That actually doesn't work. Hang on, let me finish and then you can say this. You will never multiply your a sub 1 value by your r. Okay? Say it. I will never multiply my a sub 1 by my r. Okay, remember, exponents come before multiplication, right? That's why you can't combine these. If you combine these, I will slap you with these rulers. Kind of rulers, straight edges.
Y'all hear that?
Yeah, they heard it, and I mean it. Okay?
Oh, wow.
Seriously, so many people, they'll just multiply those. Now, I know in this case, with the 1, it really wouldn't matter, but you're not allowed to do it, okay? So don't do it. You leave those separate. So then from here, the rest of this is really simple. We want to just find a sub 6, right? So if I want to find a sub 6, I'm just going to go to my calculator, and I'm going to go 1, do it. Open parenthesis, negative 5, close parenthesis, raised to the 6 minus 1 power, or most people just like to change that to a 5, because they know 6 minus 1, without having to write it 6 minus 1, right? It's pushing one button instead of 3. So you type that into your calculator, what do you get? So my a sub 6 value is negative 3,125. It's that easy, guys, okay? Let's look at another one, number 6 over here. What do we start with? Common ratio. How do we find it? A sub 2, 65, divided by a sub 1, 130. Now, when you type that in your calculator, you have 2 options. You can either use alpha y equals, because it's a fraction, or you can just type it in. When you do, you'll get 2 possible answers. 1/2 or 0.5. 0.5. Guys, am I okay with 0.5? It's a terminating decimal. 0.5 is fine. How many people would use 1/2? How many of you would use 0.5? It's kind of split. A bunch of people didn't even hear me or answer. One of the two. But let's go with 0.5. Okay? 1/2, 0.5, same thing. Here's my equation. It's this fast. It's this easy. A sub n equals a sub 1. What's that? 130. Open parentheses. Either 0.5 or 1/2. I don't care which one you use. Raised to the n minus 1 power. Done. That's the equation. That took no time. If I want to find a sub 6 now, what do? I go to my calculator. I type in 130, open parentheses, 0.5 or 1/2, raised to the 6 minus 1 power, or you could have changed that, like I said, to the 5th power. And what did that give you?
65 over 16.
So if you use a fraction, it would have been 65 over 16. If you use the decimal, it would have been 4.0625, correct?
But we don't round it.
If you did, I wouldn't mark it wrong. But if decimals terminate, I don't generally round them. It's just a personal preference. So 4.06, 4.0625 wouldn't be marked wrong. Okay? Questions about that? All right, 2 more concepts real quickly. Let's go to number 7. Sometimes with geometric sequences, they give you pieces of information and ask you to find something else. Like, for example, they give us a sub 5, and they give me r, and they want me to find a sub 1. So the beauty of the simplicity of this formula is we can just use it to find missing terms. So think about the formulas. A sub n equals a sub 1 times r raised to the n minus 1 power. And this time, what did they give me?
The R.
No, they gave me r and they gave me a sub 5. Think about this. A sub n, a sub 5. What will I put in this place? The a sub 5's value, which is negative 68. I don't know a sub 1, but I do know that r is negative 0.5. Last thing you do know. Do you know what n is?
Yes.
What?
1.
Nope. 5. How did Johnny come up with the fact that n is 5?
She did.
Nope. Maybe.
I don't know.
Move
How'd
the
you come
decimal
up with that?
No. What term did I use, guys? A sub what?
5.
A sub 5. A sub n. N is 5. Y'all see that, right? Johnny sees it. Y'all see it?
Yeah.
Okay. So all I got to do is just work through this problem, okay? So here's what I want you to do. Ignore everything else. And I want you to go to your calculator. And I want you to type in, open parenthesis, negative 0.5, close parenthesis, raised to the 4th power. That's what's being multiplied by a sub 1 right now. What is that?
0.06.
0.0625. Now here's the question. If that's being multiplied by a sub 1 right now, how do I get a sub 1 alone? You divide. What's negative 68 divided by 0.0625? That will be my answer for a sub 1. So a sub 1, what they wanted me to find, is negative 1088. So sometimes they give me problems like this where I'm given an a sub n. So that allows me to know a sub n and n. And they give me an r, and I want to find a sub 1. Sometimes, like number 8, they give me an a sub 1 and an a sub n, and they want me to find another term, so I need to find my common ratio. So here's how I do it. What do they give me this time? A sub what? What is a sub 4's value? So 4,459 equals a sub 1, 13, times my common ratio raised to what power? What is my n minus 1? 4 minus 1 is 3. Does everybody see that? Does everybody see where I got 3 from? A sub 4, 4459, equals 13 times r raised to the n, 4 minus 1 power. 4 minus 1 is 3. Now look, guys. Am I allowed to separate that 13 from r cubed? How do I separate 13 from r cubed? Divide by 13. So go to your calculator and type in 4459 divided by 13. 343 equals r cubed. Okay, last thing, and I'll have my r. How do we get rid of cube? What's the rule?
Square root.
Not square root, because that gets rid of squares.
Oh.
Cube root, right? Go to math in your calculator, math. And you can do any root in math, any root. So the cube root of 343 is, so my r is 7. Now that's not what they wanted me to find though, was it? But remember, they wanted me to find a sub 3. I had to have r to find it. Why? Because here's my equation. Ready? Y'all with me? A sub 3 will equal, what's my formula? A sub 1, what's that?
13.
Times my common ratio, which we now know to be 7, raised to what power? 3 minus 1. 3 minus 1 is 2, right? The second power. So you're gonna type in 13, open parentheses, 7, close parentheses, raised to the second power. So my answer for a sub 3 is, which that was? 637. Done. Done. What do you think? It's not too bad, right? One last thing. Turn it over to the back. And guess what? I'm not going to teach you another formula, just like yesterday. I don't think it's necessary. When we switch gears and we start trying to solve for S sub 14, what do I want you to do instead? Use the formula that we just learned, incorporate it with what? Huh?
Multiplication.
Nuh-uh.
Division.
Nuh-uh.
Adding words.
No, adding, but whoa.
Whoa.
Whoa. Whoa.
You're trying to hit me.
Don't be
Try to
trying.
hit her.
Don't be trying. Let me say this one more time because I think you guys are either not listening or you've forgotten. When we switch gears and we're now trying to find S sub 14, instead of me teaching you a whole new formula, I said, let's use the formula we just learned, but let's incorporate what?
The E thing.
The E thing, the summation thing. Because remember, when they ask for S sub 14, they're asking for the sum of what terms? All of the terms through the 14th. What does that mean? From 1 to 14. All we need, guys, is a little equation to put right here. And we know how to find it now, don't we? Because we know how to find R. How do we find R?
20 a sub 2 over a sub.
So 20 divided by 4 is 5. So look, guys, I already have my equation. It's done. Look, a sub n equals a sub 1 times r raised to the n minus 1. So you're literally going to go, and in those parentheses that they provide, you're going to do 4, open parenthesis, 5, close parenthesis, raised to the x minus 1. And it will do all of the summation for you. So how do you type it in? Alpha window, number 2, x, 1, 14, in those parentheses, 4, open parentheses, 5, close parentheses, raised to the x minus 1, enter. And what do you get? Big number, right? Big number. 6,103,515,624. How many of you guys got that?
Get some blood.
I don't know.
Billion.
Is that what y'all got?
Yeah.
So watch how fast you can do this, okay? Watch this. Look at number 11. Sum of x equals 1 to 20. For the equation, well, r is negative 27 over 81. That's negative 1/3. I reduced it. So my equation is 81, open parentheses, negative 1/3, close parentheses, raised to the x minus 1 power. Done. That's how fast you can do this. And of course, your answer here would have been 16.75. So, in my opinion, these equations are even easier than the ones yesterday for one main purpose. You don't have to simplify them after you started writing them. When you write it the first time, it's done. What size lead is it?
27.
I might have a piece I can spare.
I'm like, didn't get to write that last part.
Yeah, I'll get it. Okay.
You try.
Jace, you're gonna get carpal tunnel. I saw those little fingers, how fast they're moving, man. Just fast.
All I said was okay.
Those bullets fast.
Said okay.
Well, you said okay fast.
2 letters.
2 through 20, even. 2 through 20, even. Why are you being so defensive about it?
Why are you
Jay.
crying?
Okay.
Huh?